Hello, everyone. Welcome to this Realize Live presentation. My name is Carlos Ortega. I'm going to be conducting this presentation that is about empowering Emerson with the digital twin. Uh, First of all, I'm really happy to be again part of the Plant Simulation Conference. I'm always happy to share and to learn from everything that has been going and transpiring in a whole year. This is the third time that I'm going to be participating in the Stuttgart conference or European conference. I've been also two times in the American conference. So again, really happy to be invited and really happy to be part of it. Today, I'm going to be covering the following agenda. So first, I want to introduce a little bit about Engineering USA. That is the company that I represent right now. Then I will introduce myself a little bit. So, I hope that many of you probably already know me, but I know there's a ton more and plenty more that doesn't know anything about me. So I will get to that. Then I'll talk about a little bit about Emerson Electric. That is the company that we did the project for. Um, Pretty much, or I believe that everybody knows Emerson, at least by name. But yeah, it was a quite interesting case that we went with them in two different locations. So I'm gonna be sharing two different cases. One is a more manual. It was done in a manual line in which they were trying to find more efficiency and plan for the future. And the second case is a really straightforward case in which they were trying to do a capital equipment decision and and trying to figure out what was the best approach moving forward for an immediate investment. Um, then I'll go through some summary about both cases and how this applies and how these current models keep um, are still the meat and potatoes for plant simulation when we're facing the real world. And at the end, I will leave the space open for Q&A. In this case, of course, I will be expecting that Q&A to be conducted through email, or if you want to reach out to me either through LinkedIn or through our webpage in the company webpage, etc. But I'll get that. I'll get to that. Um, First of all, so about Engineering USA. So Engineering USA is a North American division of the engineering group. It's a global software maker, system integrator, and provider of technology, solution, and services. As an organization, we have 12,000 professionals across 65 office locations worldwide. And we manage projects in over 20 countries by designing, developing, and implementing innovative solutions for businesses areas where digitalization is having the biggest impact today. One of these areas is called digital industry. Based out of Chicago, Engineering USA specializes in digital industry, and we deliver the power of the digital thread for Industry 4.0. Besides that, um, we have four established practices, which are in product lifecycle management, so PLM, simulation, uh, MOM, which is manufacturing operation management, and supply chain management. Um, we are a pioneer in all of these. We have been working in this market since before the Industry 4.0 was created and it became a boom. We are quite familiar with all of these, I'll say, branches of the manufacturing and the digital world. And we're really happy to be always part and involved in the development and be pioneers in a lot of the different um, developments that are taking place in our current world. Then I'll talk a little bit about myself. Currently I'm a solution architect at Engineering USA. I started with plant simulation almost 15 years ago. Uh, my first interaction with it was actually going to Stuttgart and training with the old folks in there, Matthias, uh, late Dirk Moffater, Ralph, Jorg, all these guys. Which I'm really thankful for letting me learn so much through time. And at that time when I was still a young lad going through the ropes of simulation. After that, I had opportunity to work in many places. I've been part of projects for the automotive industries with many of the OEMs, a lot of the tier ones, um, uh, working on foundry or assembly or subcomponents lines, uh, uh, full interiors. Uh, man, it's just, yeah, I mean, I'm just trying to make memory, and it's really, I just go through it every time, and it surprised me. Heavy industry, appliances, electronics, MRO services. Now we're doing some aerospace and defense since I moved here in the U.S. and others. In the others, I did some projects for energy industry. So one big supplier for oil and gas companies, producing all the piping. Some investigation centers, in this case Emerson, and some other more. So I'm kind of well versed on using Plant Sim. I have been lucky enough to be in a lot of these different places, learning and doing different things, and I'm again I just feel really blessed, and on all that. Uh, Moving forward, I'm gonna talk a little bit about Emerson. So um, Emerson Electric is a multinational corporation. I mean, they have more than 250 locations. They are a Fortune 500 company. They provide components and parts and services for a number of different industrial commercial applications. And in the case of the project that we did, this was for both the HVAC solution and automation, which is creating a bit more of sensors, and the control manufacturing division. So both of them both of them are factories within the U.S. One of them is more traditional components for air conditioners. The other is more sensors to control heat units. And yeah, both of them had their own really specific differences between each other. Um, the first case is a inefficient manual process, and this was in the ANC plant, which is the one that was about sensors. Um, the biggest challenge in there, was the variation. So they had over 10,000 combination of products, and just finding the way to create a variant generator tool that was able to recreate the way they created these variations was the first challenge out of the gate. Um, they have a continually changing material flow. Um, they are also really strict on quality standards. So they go through to strict testing processes, and they are always going through either rework or retesting, or they get a number of false positives, which is part of the process. So or false positive or false negative. So they need to redo or reconduct tests, and by doing that, of course, they can create certain bottlenecks, and they could lose productivity. Um, they have a high forecast and headcount variability. So month by month, they could have changes in the forecast, and then month by month, they will need to adjust their lines in order to manage that, modifying the number of people that they allocate in these lines. And they, of course, have the changing high priority orders. So they will always have these emergency runners that will come as non-planned production, and those will throw in this array the current planning and the current headcount and the current forecast. The drivers, they were certainly looking to improve productivity. They wanted to have better control over the processes. They were trying to enhance the production flexibility. They were trying to maximize the use of resources and optimize their cycle times. They wanted to increase process quality, reduce the time to market, and go into a 0% delay for fulfillment, for order fulfillment. All these challenges and drives were fulfilled by the simulation model that we built. I mean, this is a small image and an example of what we put together for them. Of course, we went with the 3D modeling approach. All in all, what we have in here is a production line. It has the in on the top left. It goes through several assembly processes until it gets to a testing area. This testing area has three different parts of it, and depending on the different characteristics and the different specs of each of the different sensors that are to be built, they will go into the different tests. The reason I'm saying that the challenge on creating the variability and creating all the different variants on parts was difficult is because it was done through a alphanumeric code. So these alphanumeric codes will be able to go up to 20 or 23 different characters, and they will have the ones with 20 something, and they will have as little as 9 characters. And depending on the sequence of characters and the values in each of them will represent how that product was supposed to be built and which different components were in there. So creating all that system was an interesting challenge. I mean, I had fun doing it. But yeah, we were able to complete all the variants and create a really accurate variant generator for them that will allow them to test all the different sequences possible. In that front, so we did that mix generator. The other challenge for them was the dance between the stations. So as they wanted to test what will happen if I had a crew of 6 people tending everything, or 7 or 8 or 9 or 10 or 11, and how will they move in different stations to cover for the lack of having one person per station. And the results of that were quite interesting. Certainly they found that they had more leeway than what they thought regarding how many people they might need in the station to make it fully operational. They really learned also a lot about their own process, which is something that I usually appreciate on any of these projects. How much they actually keep learning from something that they know they already have everything under control, right? The process is 100% human constraint. It depends absolutely on humans. Yes, the stations are there. Yes, they have processes that are automated, and the test, I mean, is conducted on a bench, and they are not able to really interact with it. But if the person is late to take it, or the person is forgets that it's in there, or the person is not able to manage how things, the order of things, the process goes on disarray. So the main constraint and the main bottlenecks in the whole process are derived from the human interaction. So it was really important for them. And the ongoing enhancements to optimize the model. So they started to test more and more, because this is a model that we built and then we handed over. So it became their own model. They started to work around batches, and they started to work around, hey, what will be the best combination as production planning in order to get the line going all the time without setting backs and being able to fulfill their goals, and again go to this 0% delay on product fulfillment. The second project is way more straightforward. This was for this line is a line that builds a small compressor that goes into an air conditioner, and they weren't sure about what was the total investment they need to have in there. So they really wanted to make a smart decision. They really wanted to make the best investment but they weren't certain if they were doing that or not. So this was a twin line. So they were making a line from one that has already been built, and they weren't really happy or completely happy with what they did before. So when these doubts came into mind, they thought simulation was the good way to go. So they needed modularity because they were thinking on going bigger besides that. And this is a high volume production, so this is a continuous production, one part of another. They had low cycle times, and I mean low in the 20s, 30s. So it's a continuous production, and they weren't also certain that they had been really lean on the way they went through their process. Um, they wanted to reduce investments. They wanted to lower the risk through an early proof of concept. They wanted to reduce cost by making more standard tools, and they wanted also to do early validation or of the mechanical and integrated production processes, and they also wanted to do early validation of production commissioning. So based on that, this is what we made for them. Again, this is a full 3D model. We created the different robotic cells, each of them different challenges on material handling and different takt times. These two are two closed loops. So the one on the bottom of the picture is a closed loop that contains a fixed amount of pallets that are taking material to the different stations. This was one of the key components of this model because the pallets are specialized pallets. These are not your wood pallets. These are stainless steel pallets that need to specialized for kitting. So the kit of the product is included in the same pallet. So having a lot of them or having less of them would impact the total investment that goes into the project. The line on the top, it's a testing line, and the product that is created or the product that is assembled on the bottom line goes into the top line and then is fully tested in there. So we have rework loops in here. That is also one of the things that they found that was beneficial to make these rework loops smaller, and that applies in both lines, in the assembly line and in the inspection line. We were able to test conveyor signals in order to define the better way to prevent bottlenecks due to traffic jamming created because of the conveyors. We definitely were able to validate that the manufacturing cells were hitting their takt times and weren't also a constraint for the process. The most important, we proved that the number of pallets could be about 40% less than what they were expecting, creating savings instantly for the whole project. And this is one of these projects in which we were able to use Attribute Explorer just as it is in order to do the mean of all the cycle times and failures and failure rates, percentages, and everything else with that. So it was a really straightforward process on how to manage the data and how to create the outputs through Experiment Manager. So at the end of both projects, we were able to demonstrate savings across the board, both with human resources being diminished, capital resources being diminished. We were able to encounter the different bottlenecks, encounter how the utilization of certain equipment could be better. So it was a really good mix and I will say a good reward for Emerson in that sense. And definitely they were also able to look under the hood of their own data and their own information. They were able to find information that wasn't up to date, faulty information. They actually double checked a number of things in their own process in order to understand more and learn more of their own process. what I want to say about these processes too is these two processes, even though they are not the most spectacular and the most complex that you will find out there, is this is the meat and potatoes of plant sim. You get in a specific problem, you can address it with simulation, you find improvements, you find efficiencies. These two were projects that took less than 1 month to be complete. So it's a really high reward in a really small amount of time. That it's certainly where plant simulation thrives time and time again. So we don't need to find always the most complex and the most difficult things to do in order to find benefits. Um, Please, if you have any questions, reach out to me either on my email, through the company website, as I said before. I appreciate your time. It was, again, an honor to be in the conference again, and I hope you had enjoyed this information. Thank you very much.